I want to develop a formula for the sine of the sum of two angles. In order to do that, I'm going to need to recall two identities, the cofunction identities. Remember that cosine of pi over 2 minus theta equals sine of theta, and the sine of pi over 2 minus theta equals cosine theta. Remember that sine and cosine are cofunctions of one another, and in order to transform one into the other, all you have to do is replace theta by pi over 2 minus theta. And pi over 2 minus theta is the complement of theta, so you're just replacing theta with its complement. Anyway, we're going to use those two identities in our proof, and we're also going to use the cosine of a difference formula. So, what's the sine of a sum? This is the kind of thing we're looking for, the sine of alpha plus beta. So first thing we do is use a cofunction identity to rewrite this. Cosine, and back over here again, here my theta is going to be alpha plus beta. I'm going to get cosine of pi over 2 minus alpha plus beta. So pi over 2 minus alpha plus beta. And I'll just distribute the minus sign over the alpha and beta, and I get cosine of pi over 2 minus alpha minus beta. And here you see that we actually have the cosine of a difference. We've got pi over 2 minus alpha minus beta. So we can use our formula for cosine of a difference. And remember, it's cosine, cosine, sine, sine. So it's cosine pi over 2 minus alpha, cosine beta, sine pi over 2 minus alpha, sine beta. And remember, with cosine, the minus becomes plus. Now we have two more situations where we have to use the cofunction identities. Cosine of pi over 2 minus alpha is sine alpha. And sine of pi over 2 minus alpha is cosine alpha. So it's sine alpha times cosine beta plus cosine alpha times sine beta. And that's it. That's the sine of alpha plus beta. This is the sine of a sum identity.